All right, we're going to cover a couple things today. First, I need you to be at the bottom of page 30. These two graphs at the bottom of 30. Okay, and we're focused on this one first. We are going to graph both of these lines, this line and this line. And what we're going to do is find the solution to the two lines. When you have a solution, what you're really finding is where things intersect. The point of intersection is really a solution. When we solve it in algebra, we don't really see that because we do the work, numerically by hand, and we get x equals 5 or whatever for an answer, and that's our solution. But if you were to graph things, it's where they meet. That's the solution. Okay, so first thing I'm going to do is graph this one here on the left. The y-intercept is -3. That means it hits the y-axis at -3. And then from there I can rise 2 and run 5. Up 2, right, over 5. Up 2 over 5. And you can even continue in the other direction if you wanted to. Go 2 that way and 5 that way, just to keep it in line. And you get your ruler out and you make a straight line, which didn't work out well that time. There we go. So I've graphed that line. And now I'm going to graph the second line. Y-intercept of +5 and a slope of down 1. So I fall 1 and then I run 3. Down 1 over 3. Down 1 over 3. Down 1 over 3. Now it looks like I'm going to run out of graph space here, and the line's going to look something like, try that one more time, something like that. And where they intersect is like right here, which didn't appear to be in a nice spot for me to identify with the graph. So let's try this. I'm going to bring up Desmos.com, which we've used a couple of times now, and I'm going to type in y equals 2/5 x minus 3, and I'm going to type in y equals -1/3 x plus 5. And you can see the same thing happen. There was my line of 10 right there, so almost 11 comma 1.3-ish. Now that wasn't a very nice solution. We wouldn't be able to find that graphically without Desmos, but 10.9, 1.3, right? So if I was to go over 10.9, 1.3, that's just about where that point is right there. That is the solution to those two lines. Not a pretty one because it came out wacky, but the moral of the story there is when you graph two lines and where they intersect is the solution. All right, let's try it with this one. Problem with this one is, like on Friday's lesson, these are not yet solved for y. So I'm going to rearrange this by subtracting 5x from both sides. Now I have 3y equals -5x and a positive 15. Dr. Conklin showed you that at the end of last week. And then I'm going to divide everything by 3. So my final line is y equals -5/3 x, and that can reduce to +5, right? 15 over 3 is 5. So I'll be able to graph that now. Let's figure out the other one while we're at it. I'm going to subtract 2x from both sides. Leaves me with -6y equals -2x positive 12. I'm going to divide everything by -6. And my final answer is y equals, let's see, -2 divided by -6 reduces to 1/3, and negative makes a positive. So 1/3 x, and then 12 divided by -6 would be -2. All right, so now let's graph those two. I'm going to go up 5, All right, there's my y-intercept right here. I went up 5 and put a dot. Then I'm going to go down 5 over 3. Down 5, right? Down 5 over 3. Down 5 over 3 again. Down 5 over 3 again. That gives me a pretty good line. Like that. And then I'm going to do the next one. Down 2 for a y-intercept. And then I'm going to go up 1 over 3. Up 1 over 3. Up 1 over, 3. And again, it doesn't look like it happened in a nice spot because I graphed these pretty well. And that spot right there does not appear to be in like a nice coordinate integer value. So let's use Desmos again just to see what would happen if I graphed those two lines. I'll go y equals negative 5/3 x plus 5, and y equals 1/3 x minus 2. And it looks like they intersect at the point 3.5 comma negative not quite 1. 3.5 comma negative 0.8. Not a nice solution, but the point is, get it? The point is, if I went over 3.5, right? Over 3.5 and down 0.8, there I am. That is the solution to the line. So I know these didn't come out nice, but the point of learning this is where two lines intersect is considered the solution, and we'll do more of that later. All right, jump ahead to the bottom of page 33. We're going to switch gears for a minute here and talk about parallel lines, right? And eventually we'll talk about perpendicular lines. And that's how we wrap up this whole lines unit. But parallel lines have the same, let's see, if I went up and over, up and over, up and over, and the parallel line, wouldn't that be the same? So if they're parallel, they have the same slope. Parallel lines will have the same slope, which means they have the same m value, right? Parallel lines have the same slope. So let's go on to 34 for a minute and look at these three ABC at the top. Determine whether the following lines are parallel to each other or not. So are these two parallel to each other? Well, what's the slope of each one? Well, this one is a nice y equals form already. So I'm looking at the slope right there, right? Negative 1, I can put it over 1 if I want, but the slope is negative 1. Little problem with the next one, it's not solved for y yet, but the only thing I have to do is divide by 3, negative 3, sorry. And let's see, 3 divided by negative 3 is negative 1x. This would be negative 3. So what's the slope of this line? Negative 1 over 1. So the slope is negative 1. They have the same slope, so they are parallel. Let's graph those for a minute. Watch this. Going back to Desmos, I'm going to have y equals negative 1x plus 5 and y negative 3y equals 3x plus 9. That's the way it was given to you, right? Before we divided by 3. And look at those two lines. They, in fact, have a slope of negative 1. They will never meet. I could zoom out here, and they will never meet because they are parallel. Let's try the next one. Neither one of these are solved for y. That's fun. So So I'm going to rewrite this next to it just so I have some work space. I'm going to take away 3x from both sides, and that leaves me with 5y equals negative 3x plus 15. Now you have to go through and divide by 5. And when I do that, I have it in y equals mx plus b form. So my slope of this line is right here. The slope is negative 3/5. Let's see what happens with the other line. I'll do it right here since I have some space underneath it. I'm going to take away 5x from both sides. I'm trying to solve for y, right? I have 3y equals negative 5x plus 15. I divide through by 3, and I already see what's happening here. I have y equals negative 5/3 x plus 5. So if you look at these two lines, the slope of this one is negative 5/3, and the slope of the other one was negative 3/5. Those are not the same numbers. They are not the same slopes. So that leads them to be not parallel. And if we try the next one, that's in y equals form already, right? Y equals mx plus b. I can tell you right now the slope is 3 just by looking at it. The next one, 15/5, that reduces pretty nicely, doesn't it? 15 divided by 5 is just 3. So it's really the same thing as that. And look at the slope. There it is. M equals 3. So if the slope is the same, the lines are parallel. So now we have the opposite of parallel, I guess you'd call it, is perpendicular. Now perpendicular is the symbol like this. Remember we talked about it in the fall when we did proofs and right triangles and all that. Perpendicular lines have slopes that are what we call negative reciprocals. Negative reciprocals. So negative means the signs are different, and reciprocal means that it's an upside down fraction. So for example, if I had the fraction 3/5, the negative reciprocal of that, well, let's see, this one's positive, so the negative reciprocal would be the opposite sign and upside down, both. Opposite and upside down. So again, if I had 1/3, you would turn that upside down, which would be 3, or 3/1, but you could just say 3, right? And change the sign. Those are negative reciprocals. If I had the number 8, let's say negative 8. If one slope was negative 8, now negative 8 is really this, right? So the negative reciprocal would be the opposite sign, which you don't need the positive, and then turn it upside down. Those are negative reciprocals. Okay, now that we know what a negative reciprocal is, let's see if these lines are parallel. This slope is staring us right in the face. It is negative 1/1, I guess, right? And this slope is staring us right in the face. It's just not really written there because we have a coefficient of 1. So that slope is positive 1/1. As weird as this looks, 1/1 and negative 1/1 are negative reciprocals because you can't tell, but it's upside down. It's the same number, one on top, one on the bottom, and they're negative. So they are perpendicular. Let's try the next one. We'll just do one more. We'll do question B. We need to solve both of these for y first. So what you see here is I took this general equation, I subtracted 3x from both sides, right? And then I divided them all by 5, and I got our final answer of y equals negative 3/5 x plus 3, which means the slope is negative 3/5. So this time I took this equation, added 5x to both sides, divided them all by 3, and that was my answer, which showed a slope of 5/3. 5/3 and negative 3/5 are perpendicular, negative reciprocals.